Okay, good morning, all the participants. Myself, Dr. Arindam Maiti, the Associate Professor of Department of Pharmaceutical Technology and Pharmaceutical Technology, JIS University. Welcome you all for the first sessions of the FDP, and that is entitled recent trends in pharmaceutical and biomedical research. It is my great pleasure to introduce Professor Nanda Gopal Sahu sir. So he is a professor of that is Department of Chemistry, Kumaon University, Nainital. Professor Nanda Gopal Sahu earned his PhD degrees in material science from one of the prestigious institute in India, that is Indian Institute of Technology, Kharagpur, from 2004. After pursuing his PhD degree, he worked in the several countries with eminent scientists and professors in a wide spectrum of research field and gained expertise and scientific orientations in several streams. He held the scientific positions in 2012 to 2013 in Institute of Material Research and Engineering, Astor Institute in Singapore. Prior to this, he was attached as a scientist with Energy Research Institute and at Nanyang Technology University, that is NTU, popularly known in 2008, from 2011 to 2012. In 2008, he is awarded one of the most prestigious award in Singapore, that is Lee Kuan Yew Fellowship, which is awarded him for 3 years in School of Mechanical and Aerospace Engineering, NTU. Prior to that Lee Kuan Yew Fellowship, he had an opportunity to work as a research fellow at the School of Chemical and Biomedical Engineering, NTU, from 2006 to 2008, and that is an artificial muscle research center, Konkuk University, South Korea, from 2005 to 2006. After work with several years with different eminent group, Professor Sahu joined in Department of Chemistry, Kumaon University, Nainital, as an associate professor in 2013. Later on, he is promoted as a full professor in 2016. He worked for establishment of the first nanoscience and nanotechnology center at the university. He was among the best fellow personals in the Indo-US Science and Technology Forum for advancing their research in the field of solar cell development in Virginia Commonwealth University, USA, in 2014. He was received multiple awards. He is received a prestigious award as a research experience in 2014. He received the National Award in Technology Innovations from the Ministry of Chemicals and Fertilizers, from Department of Chemical and Petrochemicals from Government of India in 2018. He also received the prestigious Uttarakhand Governor Best Research Award in 2017 and Uttarakhand Ratna in 2019. His international and extensive research experience has allowed him to significantly contribute to in many areas in research and development, such as solar waste management, energy storage, conversion, drug delivery, polymer nanocomposites, polymer chemistry, particle technology. He also worked as a visiting scientist at Free University Berlin, Germany, and Konkuk University, Seoul, South Korea. As per his research achievement to date, he is published 105 journals in the prestigious international journals, in high quality research international journals, and 10 patents, out of which 2 are already granted and 8 are filed in the process, and presented 86 papers in international and national conference and symposiums. His total citations, according to Google Scholar, is 8,200 and H index 637. I personally know Professor Nanda Gopal Sahu from last 5 years. He is one of the inspirations for me as a research scholar to do research during my teaching period. So I welcome Professor Dr. Nanda Gopal Sahu, the first sessions of this FDP. I hope that all the participants will enrich his vast knowledge and research experience. Now over to Dr. Nanda Gopal Sahu sir. Thank you.
Thank you, Dr. Indram, for your introduction, and also thank you for your invitation to, so my work, whatever I have been doing in Kuma University, Nainital. And good morning to all participants. I hope this is your first day. So I'll try to give a brief about my work and also, the waste to wealth, how we have developed the technology using the, from solid waste. And also, I will also show you some applications, definitely in drug delivery and also other applications. So now I'm going to share my screen. So Dr. Indam, so I can start it right now?
Yes, sir, you can start.
Okay, so I'm audible, is everything is okay?
Yes, sir. Sir, your screen is visible, sir.
Visible, right? Okay.
Yes.
Just 1 minute. Okay. So actually, today I keep my topic actually waste to wealth, a green and sustainable roadmap for conversion of the solid waste to value-added products and their applications. I think everybody knows. The nowadays what is the problem of the waste, and big problem not only in India, also in the uh, much more developed country also, they are facing a lot of problems to control the waste. And actually there is different type of waste uh, sorry. Yeah, there is different type of waste, actually industrial, agriculture, sanitary, and solid urban residues. But actually out of this there is a huge problem in the management of the waste plastics. Why? But there is a plastic that we can say there are two types. There is a biodegradable and non-biodegradable. So for the biodegradable, there is okay, we can manage anyhow. But for the non-biodegradable polymers, it is very difficult to collect segregations and upcycling of the waste plastics. And what is the problem actually for the non-biodegradable problem, non-biodegradable plastics? I can show you the next slides. And before that, so you can see in the left-hand side, in the figures, you can see that every year the production of the plastic is increasing near about 10 to 11%. So it is very difficult to stop the production of the plastics because they have many advantages. I will also tell you later. But how we can manage it? Because we can use the plastics, and because of the plastics, our daily life become very easy. Because nowadays you can see everywhere actually in our utensils and everything made by the plastics. So we cannot deny the advantage of the plastics. But problem is that when we can throw the plastics here and there, that is the main problem, because we are not aware about the problem of the waste plastics. That is the main things. So how we can develop the technologies to utilize the waste plastics and we can save our environment. That is a big challenge in front of research community. And you can see nowadays there is, some technologies are there. They can converting the waste plastics to oils. But the problem is that, the production cost and in product cost, there is not much more difference. So that's why it is difficult to sustain this type of technologies in India. That is a big problem. So the main problem actually, if we can throw the plastics here and there, what is the problem? Main problem, the in city, there is the municipalities and then the village area in the panchayat, right? So there is no any systematic way to collect the plastics and segregate and also transfer and disposal of the plastic waste. And because of this non-biodegradability nature of those plastics, when you can throw it, sometimes the choked of the drain. And also is the plastics is make land infertile and also ingestion by the cattle and lead to death. I will show you also. And not only that, if the choke the drain in the moon, sometimes it happens in the flat. That is a big problem. And also in the sometimes in the hill area also the flood because of the waste plastics. I will show you the one video also. And most of the part actually in the village side, if you can go to the village side, you can see the people, common people can burn the plastics. So if we burn the plastics, the plastic generates the toxic gases such as carbon monoxide, chlorine, hydrochloric acid, dioxin, furans, and means many gases come to the environment and pollute the environment. And also during processing of the plastics, different type of metals can be used such as lead, cadmium, phthalates. So if you can throw it, these toxic metals leaching out slowly and pollute the environment. And another problems, actually the government nowadays banned the use the plastics the thickness below actually thickness 50 microns. So the question may be arise to the below 50 micron plastics cannot pollute the environment. No, this is not true. Actually, the below 50 micron plastics, it is very difficult to collect and segregate. That is the big problem. So because of that, government banned the below 50 micron thickness of plastics. And one more thing, when we get to garbage, and this garbage actually is mixed with the plastic. So that is very difficult to separate the plastics from the liquid garbage and also the solid garbage. That is also the very big issues. So that's why we need the systematic upcycling technologies to collect, segregate, and utilize the waste plastics to save our environment. So before actually I'm going to discuss about the different technologies. So I have just preliminary knowledge. What is the polymer? Actually, plastics the polymers. So what is the polymers? So polymers, you can see the poly means many and mar means unit. Where the many units add each other to form the high molecular weight. So that is the actual polymers. Because when they form the polymers, the strain, mechanical strains is huge compared to the monomers. But you can see that, there's a backbone, actually main backbone chain, there is the carbon linkage. Yeah, that is our main things, how we can use this carbon to develop the technology. And there is a different type of monomers, the ethylene, propylene, styrene, vinyl chloride. But when they can add to each other, there is an number of repeat units of ethylene, they can form the polyethylene, polypropylene, polystyrene, and polyvinyl chloride. So actually, we are discussing about the disadvantage of the plastic. Actually, our our nature, main nature is we can find first we can find the disadvantages, but that time you cannot consider the advantage of the any product or any persons. So that's why. But there is a lot of advantages for the plastics, because plastic is very resistant, high durability, and also insulator, and very inexpensive and easy to produce. And because of that, the plastics can be used in every field. There is the textile fiber, packaging, automobile, agriculture, infrastructure, so electronics. So we cannot deny this type of applications. But only problem is, after using, if we can throw it, that is the problem. And if we can collect and segregate and utilize the waste plastics, I think we can save our environment. Actually, this is the picture, that is our picture in hill area. Actually, I'm staying in the hill station, so you can see how they can dam the waste plastics in the land. There is the huge plastics are there. Not only that, also in lake also you can find a lot of plastics. And not only that, these plastics also, if you can throw it, sometimes the cow they can eat, and also the tortoise also can eat the plastics as a food, and they can die. And recently, actually, this is, you can see that recently, the just 21st February 2021 in Faridabad, India, near about 71 kg of waste, including plastic, including nails, were obtained from the cow stomach, but the animals, actually, her baby died later. So the lot of cows roaming in India, actually road, and they can eat the plastic as a food. So we have to save them. So that's why we need a technology to utilize these plastics, and also we can save our ecosystems. Yeah, just I will show you the one video. Yeah, you can see the video. Actually, this is the Himachal Pradesh, just 2018. And there is a river. From the river, you can see in the river. And from this river, the water supplies into the nearest villages. But you can see the plastic rivers, Yeah, a lot of plastics in the rivers. So these plastics, you can see how they pollute the water and also our environment. Yeah, this is all plastics. So you saw the videos, and you can see how we have polluted our water through the waste plastics into the river. But actually in India, if you can think about that, using actually the per capita, if you can compare with the other countries, that is the US, Europe, China, and Brazil, but this is a more very less. That's only 11 kg per capita you can using it. it is very less. Actually, if you can compare with the US, there is the people are using near about 109 kg. But problem is that our population is very high, and because of this very high population, so the plastic waste generated is very high. And one more thing, for the near about 60% plastics, waste plastics recycling in India, that is also highest actually compared to the other country. But this recycling in India definitely is in unorganized way. That is the big problem, big issues. So how we can solve it? Actually, our vision that how we can develop the green technologies to save our environment, and also we have to develop the upcycling waste materials. If we don't develop any value-added products, that will be a problem. We cannot sustain the technology. So that is the main point. So develop the value-added product and greener technology. These two. So if we can do that, definitely we can save our environment. Already I told you that in India, that is near about the plastic with generation near about 25,914 ton per day, and out of this the collection near about 15,564, near about 60% of the total, and near about 40% is uncollected plastics, and this is a very huge problem. So I think the next few years, after next few years, it's very difficult to control the plastics waste. And if you can consider, there is a different type of plastics. The most of the plastics you can see, that is HDP and LDP, near about there is a 76%, and just polypropylene, the 7%, PS 10%, PET 3%, other plastic 3%. So how we can utilize, actually, the LDP, ADP, and PP are the most actually, just near about, most of the, you can consider near about 90%. So if 90% plastics we can utilize, so that times we can save our environment. So there is actually different technologies are there for the recycling of the waste plastics. There are defined the mechanical, chemical, and thermal. The mechanical means only the crush the plastics or melt, and then again we can use it. Don't actually change the chemical structure. This is also people using actually plastics used in the road also, but when they can utilize the direct plastics in the road, there is another problem will be arised after a few years, because we cannot solve the microplastics. After several years, the microplastics also come out in the road. So that times how we can control it? There is a big issues. And one more things in the chemical recycling. So chemical recycling means they can also convert the monomers and other monomer, and then also you can use the develop of the other polymers also, but this is the more expensive process. So last is the thermal process. But in thermal process, actually you can, the few years back, the people can use the incinerator to, the plastics, burn the plastics, but now the government also banned the incinerator, because in the incinerator that's very difficult to control the toxic gas. So toxic gas will be come out the environment and pollute the environment. So now, one more actually left, the one more, that is the pyrolysis. So in thermal process, actually we can use the pyrolysis, and in case of the pyrolysis, we can get the fuel. Actually, most of the technologies, they can develop the fuel. But in our case, we are not very much interested about the fuels. I will show you from this thermal process, actually, we have developed the technologies and we have developed the value-added product. Yeah, this is the thermal process, and this pyrolysis process. You can see the the black chair, and this black chair you can utilize, actually you can utilize to develop the graphene. I will show you what is the graphene, and I also discuss you. But nowadays, actually, we are using the all the plastics except PVC. Yeah. So our main actually aim and objectives you can see that the synthesis of the graphene from the plastic waste for the energy and biomedical applications, and to develop new, cheaper and green technologies for the bulk production of the graphene from plastic waste. So question may be arise, what is the graphene? Actually, graphene actually nothing but actually it's the single layer of graphite. There is a two-dimensional and sp2 hybridized. There is a honeycomb structure, and there is a very high surface area near about 2630 meters per gram, the surface area of the graphene. And actually you can already see the actually pencil lead, and from the pencil lead in 2004, the Professor James and Nobles of Manchester University, they developed the graphene from the pencil lead in the the Scotch tape method, and they actually went to the single layer and they named this the graphene, and they got the Nobel Prize in 2010. So why they got the Nobel Prize within 6 years? Yeah, this graphene can be used in everywhere. I will show you. So from this graphene, also we can develop the, this is when from the tube form, there is the carbonate tubes, where you can see the, two layers, there is the double layers carbonate tubes, and about that there is a multi-layer of carbonate tubes, and also we can develop the buckable, there is the fullerene. So we can say the graphene is the mother of graphite. So why graphene is very important? Okay, before going to that, so you can see the ages, right? So that is the the Stone Age. Earlier, actually, you can find it: the Stone Age, Bronze Age, Iron Age, Space Age, Nuclear Age, and the last, the Information Age. But now that is the graphene age. Means this graphene can be used everywhere. That is, in electronics they can use the graphene, and biomedicals, composites, the energy, everywhere they are using the graphene. But the problem, there is a big issues are there, that is the production cost of the graphene, and also it is very difficult to develop the bulk amount of the graphene, because in the market, that nowadays the graphene actually very high quality graphene, that is near about 1 gram graphene cost near about $1,000, and that definitely this type of graphene can be used in the electronics applications. But if you can consider in the India market, there was the multi-layer of graphene, the cost is that is 30 to 40,000 rupees per kg. So if we can reduce the graphene cost, that time the graphene can be easily used the various applications, and industry can use the graphene into their products. So yeah, so why the graphene is important? Actually, graphene, these mechanical properties is very high, and these mechanical properties, very high compared with the steel also, and also the conductivity is better than copper also, and also very high surface area. But there is big challenges: difficulty in high quality and high infinity management to develop the graphene, and the graphene process, there is the time consuming, and definitely the difficult in the mass production of the graphene. So that's why we actually tried to develop the graphene from waste plastics. So why not we can develop? Because in the plastics, I also already showed you that the backbone, there is a carbon chain, because there is a very high carbon, more than actually 60% of carbon are there. That depends on the nature of the plastics. So why not we can utilize this carbon, and this carbon we can convert to the graphene. And this concept actually we can utilize, and also we have developed the technologies. And this one, the actually waste plastics, and from waste plastic we can categorize different the plastic is polyethylene terephthalate, HDP, LDP, PH, PP, and other. Then actually washing, measure cutting, minor cutting, and drying. And after that, actually, we have developed the machine that is the Swambhu waste recycling machine 2021. And you know the meaning of the Swambhu, that is the Sanskrit word. So I'm going to describe about that. And after this using this machine, actually that is the mainly nothing but the actually pyrolysis. So this pyrolysis machine we can utilize some add the catalyst, and catalyst after that we can use the valued fuel and also the carbon nanomaterials. Yeah, for initially actually in our lab, just 2016, just we bought a reactor from the market. Just only this reactor, these reactors only we bought just 5,000. Actually, spent the 5,000 rupees. And from this reactor, actually we utilized the waste plastics, and we developed the graphene. And after that, we applied for the fund. Actually, I joined the university in 2013, right? And 2014, so I went to the US, and again I came back in 2015, and just I started my lab in 2016. So that times, it is very difficult to get the fund without any initial work. It is very difficult to get the fund, and also we are from the very small universities, the state university. So it is also very challenging to get the fund. Anyhow, we have developed the technology, and we approached to Ministry of Environment, Forest and Climate Change. And fortunately, we got near about 2.2 crore rupees from Ministry of Environment. And after that, we have developed our recycling machine. Yeah, this is our recycling machines. This we actually named this is a Swambhu 2021. Why? And this is actually cutter. Okay. This is a cutter, and this cutter we can actually crush the plastics into the very small pieces. And actually it depends if what we want actually the end product. Actually our aim was to develop the graphene, so that's why we made the cutter accordingly. And after that, the next one, this is the washing. And after washing, actually next one, that is the drying. And after there is one more, this is the mixing. We can mix with the catalyst, and this is the main chamber. This is the pyrolysis chamber, and this pyrolysis you can run in nitrogen environment. And this pyrolysis chamber, you can see that there is a different type of filter are there, and also the condensations are there. So if we can, the plastics, heat the plastics up to, we optimize the condition, and if we can change the temperature and pressure, actually 5 degrees centigrade, if we can change, we don't get the high quality of graphene. It depends on the all parameters. And initially, actually, we start this machine using the diesel engine. So after 10 minutes, you can see that there is some toxic gas, definitely toxic gas will be evolved. So that times we can stop the machine. And these toxic gases actually, 1 to 4 carbon. So these gases come to, there is you can see there is a pipeline. So they can come to this pipeline and run the instrument. So we don't need that times the energy from the outside. So these gases we can utilize. So these gases not come out to the environment and don't pollute the environment. And higher hydrocarbon, here are going to go to this one, and there is a condenser, and then we can get the fuel. And from here we can get actually the raw graphene, and this graphene, this is the ball milling, and we can use the ball milling to do powder shape of the graphene. And there is one more, is the secondary unit, and this secondary unit, we can heat up to 800 degrees centigrade to 900 degrees centigrade, and we exfoliate the graphene, and we can get the pure graphene, and then after that also we can wash it. This is actually about 100 kg per day capacity of our instrument. We can utilize the 100 kg plastics per day. Okay, Dr. Orindam, hello.
Yes, sir.
Yeah,
Still.
so still okay?
Yeah.
Audible. Yeah, okay.
Yeah.
And also, I request participants, please also respond it. Otherwise, it is very difficult to know you are listening or not. Just I am giving the lecture, and I am giving my energy, full energy, but you are not listening it. So that is the waste of my times also, and also my energy also.
Yeah, that's fine. Good. So dear participants, you can unmute and you can interrupt as
definitely. I think it will be better, right?
Yeah, you can interrupt.
Okay. Anyhow, Anyhow, I will also show you the whole process, actually, graphene manufacturing process, and also you can see also. Okay, you can. You can see. I will show you the whole process, and you can see it, and I hope you can enjoy it also. Okay, this is the step by step. This is the mixed plastics. We can collect the plastics from the flea market in our non-Italy area. Yeah, and when we started this work, we bought. The participants, please mute your mic. Mic, please. Yeah, mute your mic. When you can ask the question, that times you can unmute your mic. Okay. So anyhow, so we bought actually the plastics. That's only 10 rupees per kg. But nowadays we are buying the plastics that is 35 kg per 35 rupees per kg. So the economically growth actually the and because of that actually because of that we don't need the collection individually. They can collect and segregate and they send to our center. Okay, so this is the mixed plastics, and after that, this is I already showed you the kata units, and then you can see that the crushed plastics, and this is the washing, and after the drying, and after drying, this is the the mixing with the catalyst, and that is the pyrolysis unit where you can heat the whole plastics and raw graphene, and after ball milling after this the secondary unit where we can heat up to 800 to 900 degrees centigrade, and we got the pure graphene, and then washing, and then this is the graphene. And this is actually we have already got this patent. Yeah, just I am going to show you the video, and sorry. Yeah, this is actually our hello. Yeah, this is our nanoscience and nanotechnology center, Combined University. I think please mute the mic, please.
Sir, all are
Hello.
muted, I think. All are muted.
Oh, okay. So yeah, this is, you can see, this is the plastic. We have used the PET bottles, and you can see that this is the glass plastics. And after glass plastics, you can see this is the washing. And after washing, this will go to the drying unit. And after drying, this is the mixing unit where we can mix with the catalyst. And after mixing the catalyst, this is the pyrolysis chamber. Pyrolysis chamber. And we can create the nitrogen. Whole process can be get under the nitrogen environment. Yeah, this is a nitrogen environment. And after that, this is the diesel engine. We can start the machine. And yeah, this is the all pipelines you can see, and this is, you can see the crude oil, and this is the raw product. And that's one. We can use the ball mill to form the powder, like a powder form. And this powder form, yeah, we can use in the secondary unit and heat up to 800 degrees centigrade. No, 800 degrees centigrade. And then we can get the graphene, and this is the whole method. You can see that. Yeah, this is yeah, this actually using our the graphene, you can see this, you can use the dye, and we can get actually, the pure water. Near about 99% dye can be removed using our graphene. I will show you also later. And this is actually different type of graphene, the quality of graphene. And actually my earlier group is not in the group now. It is actually near about 14 to 15 students are working under my supervision. And this technology, whatever we have developed, it has been taken near about 2 years to optimize the process. And one more thing, this was not easy to install this one in our center, because this is the hill station, so it is very difficult to bring it. It is from the Mumbai, actually manufacturers in the Mumbai, so it was very difficult actually. And not only that, when we installed this one, we went to different peoples. So no one actually allowed us to install this machine, because nobody knows what will be happen, and they also did that time, they did not know the toxic gas will be come out or not. That's also the very big issue there. So because of that, we struggled a lot. And last, actually, our head of the department uh, told me that you can install it. I can see the other matters. So I'm very grateful actually to our head of the department and everybody actually, they're helping me a lot. And some people are there also, criticize you. When I started this work, also they were laughing and they told that, साहू जी तो हवा में काम करते हैं, है ना? But after develop this technology, and because of the technologies, actually, I have awarded the 8th national award, and that people now they came and congratulate me. So when just I tell you, all the participants now, you are much more younger, so please don't think about that. You have a limited source. I have also the very limited source. From limited source, you can utilize it, and you can do, if you think that I have to reach my goal, definitely you can. So don't worry, you can try it. And some also participants actually many times ask me, sir, I am from the college, so how I can do the research? But this is not an excuse. From college, I know many people. Yeah, I know many people who came from the college also. They are doing very good work also. But problem is that how do you spend your time, and also how spend your life? If you want it, like you can live in as a general peoples, you can. If you think no, I have to do something, you can. This is not a problem. Yeah, definitely you have to overcome some hurdles and something like that. So you can do that, I hope. Anyhow, so this this technology actually, this this technology already transferred with the help of National Research Development Foundation, Government of India, to one company. And not only that, nowadays another two, three industries from abroad also, one from New Zealand and one from Singapore also, they contacted us, or also NRDC. They are very much interested to take this technology. Why they are interested, I will tell you. Before that, initially, when we started this work, you can see the surface area of our graphene very low. That is near about the 100 meters square per gram.
And sorry, sir, sorry to interrupt you, sir.
Yeah,
excuse me, sir. If you kindly allow me, I have only one question.
Yeah.
So from this discussion, we came to understand that there is development of some carbon nanomaterial.
Yeah, right.
Yeah, and carbon nanomaterial, maybe carbon dot, carbon quantum dot, graphene, many other things, fuller and many things, nano diamond. So how to prove that it is graphene?
Yeah, just I am coming to discuss your point. Definitely, I have to prove it. Otherwise, the why people will accept our technology, right? So that's I'm going to that point. Okay, this is actually characterization. So that's why I'm telling you, this is initially the surface area, developed was just only 100 meters square per gram. And also you can see here, the Roman, actually there is a D peak and G. There's a two main peaks, D and G. D peak, yeah, D peak because of the, sorry, this is because of the defects, means carbon to carbon single bonds, and G band because of the double bond. Actually, much more purity, this shows the purity. And another peaks will be come to the, yeah, this is actually 2,500, near about 2,500 to 600 is a 2D peaks. And from the 2D peaks, you can see that how many layers are there. So initially, we didn't get it. So we repeated a lot of experiments and we changed the parameters. Yeah, change the parameters, everything. So that's why I told you we have started this work 2016. Actually, we have installed the instrument about 2019, last of 2019. Yeah, no, 2018. Yeah, last of 2018, and fully we have developed, 2020. Right. So now we are getting near about the graphene with the surface area near about 400 meters per gram to 700 meters per gram. And also you can see there is a 2D peaks also are there, and there is the TM, and from TM image you can see, I will show you the many TM images are there, and there is a two-dimensional, the layers and the stack to each other. So that is the graphene, because the carbon dots or others, you can see that is the like a the spherical shapes. So that's not the dot shape actually. So that is not, this is the not also the carbonate tubes, because if you can get the carbonate tube, that is you can see the tube form, and that is the graphene. And I also show you the graphene nano ribbons also, and also three-dimensional graphene also I will show you later. Okay. And there also we confirm from actually the XRD and TJ, and also the DFT studies. From whole studies actually we have confirmed, UV also, FTIR, and everything we have studies, and then we confirm that is the graphene, and already have published, and already we got the patent. And we published a lot of papers, and also recently also we published in Nature group also, scientific reports. And yeah, so what about actually initially, I told you initially it was very difficult for us to get the conductivity, because without conductivity, we cannot prove it is the graphene or not. So it is very difficult at times. So now we are getting the very high actually conductivity. This is the wire, and this wire we actually cut the inside, and we can add the graphene, and you can see that the glow of the bulb. Yeah, this is the graphene. Yeah, this is a graphene. Yeah, you think the bulb is glowing. So that's why actually this is the practical work. So our graphene should have very high conductivity. And main important part, the cost analysis. Why the industry has interested to take this technology? Because if you can use nearly 100 kg of plastics, 100 kg of plastics, all cost, energy, manpower, raw materials, everything we have included it. So that is the cost near about 10,000 rupees. But you can see that we are getting near about graphene 15 to 20%. So that is 15 kg to 20 kg of graphene. And liquid fuel 25 to 30%, and gases for 35 to 45%. So you can see, if we can consider this is the 15 kg, because it depends on the actually plastics. For the some plastic, if we can use only polypropylene and polyethylene, that is you can get the the more graphene, and maybe others which you can use this, we can get the lower graphene. But if you can use the mixed one, that will be the better, because the polyethylene terephthalate, there is a functional group, there is the oxygenated groups. So sometimes if we can use only polyethyl terephthalate, it is very difficult to control the process because there are more gases come out. And so that's of the pressure will be increased. So that times it is very difficult to control the pressure. So that will be better if we can use the mixed plastics. And that's why if we can get the 15 kg graphene, so the cost definitely near about 600 to 800 rupees per kg graphene, and industry can sell it. If they can sell, actually now I know our graphene, the industry are selling near about 15 to 20,000 per kg. The industry, which industry has taken the technology, they are selling this graphene, and our graphene, and not only the India, also they are selling into the abroad also. So you can see how much profit they are getting. So that's why actually the many industry also they are interested to take this graphene, and actually this graphene actually they can use for the conductive paint, and for the tire industry, cement industry, and also so anti-corrosion actually paint they are using it. And but not this plastic. Also, they are using also the supercapacitor, actually supercapacitor. And but this graphene actually can using the electronics, because electronics need the more actually purified graphene about the single layer graphene. But it is very difficult to develop the single layer of graphene from these methods. But still, we are trying to get high quality graphene, because nowadays we are getting the graphene about 3 to 6 layer of graphene. So we are trying to reduce the layers, but still research is going on. And you see the graphene market, why the graphene? So graphene market already actually reached in 2020 about $126 million. So you can see that every year graphene market is increasing. And 1 gram graphene, that is actually the sigma LD, from the sigma LD, so that is the very cost. You can see that. But in India market, however, I told that it depends on the quality, and definitely you can get the 30,000 to 40,000. And also, nowadays, whatever you can develop, the Chinese can reduce the price. So Chinese companies also, they are also getting very less price also, not less than 10,000. Okay. Yeah, also we are getting the fuel. So actually, we are not very much interested for the fuel, as this technology already developed, and some people are also working on that. So only we are concentrated on the graphene. So now I'm coming to the how this graphene can be utilized. So we can use actually graphene in different actually different sectors, from the structural applications, aerospace applications, maritime polymer nanocomposite, water purifications, energy, fuel cells, solar cell, and energy storage, supercapacitor batteries, and also drug delivery, and microelectronics and conductive composites. But in our group, I've been working on polymer nanocomposites, water purifications, fuel cells, solar cells, supercapacitors, and drug delivery. I will show you some results. But before that, initially, actually, we have used this graphene can be used as an additive to develop the concrete mixture or not. Actually, with the help of civil department in Gafigara University, we have mixed our graphene into the cement. Actually, about 0.5%. Actually, we have used a different percentage, but we got the better result in 0.5% of graphene according to the cement. And this we have developed this block, and we tested it like near about the compression strength. You can see the compression strength near about increased 40% using 0.5% of our graphene. So why not? This graphene can be used as a road construction. Definitely, we can mix in the cement. Yeah, somehow, sometimes increase the cost of the cement, but increase the durability. So that's why we have made the graphene road in our center. I don't know, Dr. Anirban saw this road or not.
Yes, yeah, yes, I see in it.
Okay.
Yeah, during your conference, I see.
Yeah, so I think we made this road, the graphene-based road, and nowadays actually the DRDO also contacted us already to develop a road in their campus also using the graphene. So actually, initially I told that the people actually using the waste plastics directly to the construction of the road. Yeah, the cost not increased in that case is not a problem. But problem is that how we can solve the microplastic problem, because after some periods the microplastic has come and also pollute our environment. But if we can use the graphene in the road, definitely there is no harmful, nothing, and durability also increase a lot. Yeah, and this graphene actually, this graphene already I told you we are working on that. We're trying to develop the water filter, and already we tested that most of the dye actually can remove near about 99%, and some metal also removed from using our graphene. And still actually we are working on that. I think very soon actually we can develop our water filter, and definitely it will be the cheapest actually. I hope so. And actually, I just forgot to tell you, after that develop this technology, so Ministry of Environment, Forest and Climate Change have given us near about 3.5 crore. And 3.5 crore for installed near about 1 ton capacity. 1 ton capacity recycling machine in Nainital area. And just we are going to install it, the recycling machine and also segregation unit. Then segregation unit near about 20 tons, 30 tons segregation unit in Nainital area to remove all waste, not only the plastics, all waste from Nainital district. I hope within this year we will be able to install them. And definitely our dream to solve this waste plastic problem, not only in the Nainital region, also in India also. But one more thing, just I told you, we are from the very small state university. That's why it is very difficult to publicity actually to all over India. Anyhow, it's not a problem. So we are doing our work. Okay. Not only that, that is for the plastic waste. Also, we have developed our graphene actually from the waste, the papers. And if we waste paper recycling in, the cost will be higher than upcycling of the waste paper. So that's why we have developed the technologies, and we have developed actually high quality actually 3D graphene nanosheets from paper waste. Already have patented, and already have submitted the paper also. I'm not going to discuss more because now already, I think 25 minutes left, right? Okay. Also, we have developed the graphene nano ribbons, using the cotton waste. And knowledge that also we have developed the graphene actually from agricultural waste. We are staying in Untitled region, and there is a lot of forest. And sometimes also you can see from news channel that there happened a forest fire in summer times. So because of this oak leaves. So if we can use these leaves and we can develop the graphene, so I think we can save our forest. So that's why actually we have tried it, and successfully we have developed it, and already we have filed the patents and also published the paper also, and patent already also this is also granted, and this patent. And this case also, we have developed the originated potassium doped graphene oxide from oak fruit. So we don't need to add the metals outside from outside. That is already there. So we developed the potassium doped graphene oxide, and this is fully water soluble, and because of this character and this very good fluorescence properties, and because of these fluorescence properties, we can use bioimaging applications, and that is actually this graphene can be used with biomedicals, and that's already published the paper. And not only that, and these potassium doped graphene oxide also can be used the detection of the iron in water. That is, we can go to the 7 ppm level. Yeah, that is the characterizations, different characterizations, and that is the graphene from TM. And there is different characterizations, also the fluorescence, so the fluorescence. Yeah, you can see, actually we can detect the visual detection of iron. Actually, we are just trying to develop the sensor using this graphene oxide. Like we have already did the we put our graphene inside the tea bag, actually like a tea bag, and we put in the iron this water, and then you can see the change the color. So that is, you can detect that there is whether there is a iron is there or not. Yeah, that is, you can detect up to 7 ppm level. Yeah. And not only that, also we have developed the graphene from pencil lead. Whatever you can throw it, we can collect and we can develop the graphene. And that is, I will show you the video. Yeah, that is actually, this is my collaboration work with Singapore. This is actually electrochemical method. There's, you can see the pencil lead and another electrode, that is the platinum, and we use the electrolytes, that is the dilute H2SO4 and dilute phosphoric acid, and we have applied near about 7 voltage. So these 7 voltage is enough to drive the anion to the cathode positive electrodes and exfoliate the graphene. And this process, you can see that this is the upper layer, very light, actually lightweight. So this is the graphene, and this is the layer near about 3 to 6 layers of graphene. Yeah, now I am coming to your main topics. This graphene can be used in the biomedical applications. They can use the cellular therapy, antimicrobial effect, photodynamic therapy, and drug delivery, and also they can use as a cancer therapy, bioimaging, magnetic imaging, also dual drug delivery, and drug and gene delivery also use actually graphene as a nanocarrier. So there are different type of actually nanoparticles are there. So do you know that nano? I hope so. What is the nano? Hello, participants. Do you have any idea of the nanoparticles?
Participants, please answer anyone.
If the particle size is below 100 nanometer,
Yeah,
then it
that is
will
the
be
one.
said
Yeah, that is the 1 nanometer to
but
100
for drug
nanometer.
delivery, its size may be up to 500 nanometer.
Yeah, that is okay. So that's why actually the nano means basically we can say the nano 1 to okay, just mini, and 1 to maximum 100 nanometers. So that is, you can say the nanoparticles. But apart that is a sub. Actually, nowadays many people can write also 200 nanometers, 300 nanometers. That is up to them, because this is a sub micron particles. So that's why this is a nano. Actually, you know, sometimes your some general publics, what is the nano? If you can say there is a 1 nanometer to 100 nanometers, but they don't understand that this is a nano because we cannot see the open eyes, right? So that's why actually I have given most of the cases I give the another definitions, the nano, है ना? So I'm giving in the Hindi the nano, है ना? So I'm giving in the Hindi, right? आप लोग तो हिंदी जानते हैं, so हिंदी में बोलूं participants?
Yes, sir. Yes, sir.
Okay.
It's okay, sir.
Okay. So हिंदी में बोलते क्या? जब नैनो क्या है? कि ना देखे आप घर में काम वाली भी आ सकते हैं, काम वाली भी पूछता है, अरे भैया आप बोले नैनो क्या है? साहब में तो नैनो कार भी आ गया, सब का आ गया. सर नैनो क्या बोलते हैं? तो आप क्या समझाएंगे? That is 1 to 100 nanometers? No. तो मैं एक बात बोलते हैं, जो देखता है वो बिकता है, राइट? जो देखता है वो बिकता है, और जो नहीं देखता नहीं, जो नहीं देखता वो ज्यादा से ज्यादा बिकता है. That is the concept of nano. ठीक है? Okay. So now I am coming to the nanoparticles. There is different type of nanoparticles they are using in actually drug delivery applications. These are dendrimers, liposomes, quantum dots, metals nanoparticles, magnetic nanoparticles, polymeric nanoparticles, biological nanoparticles, gold nanoparticles, carbon nanotubes, and also they are using also graphene. है ना? So why they are using in participants, please mute your mic.
Dear participants, please mute your mics.
Yeah. So why these actually nanoparticles mostly they are using as a nanocarriers, right? So why they are using in the drug delivery applications? But most of the people, you are from the pharmaceutical background, I hope you know better than me actually, because I'm the chemistry and we are doing the other field. So actually the nanoparticles, they cross the cell membrane very easily and permeate the cellular uptake of small molecules very easily. And because of that large surface area, many actually drugs or proteins, they can attach at the in the surface of the nanoparticles very high compared to that. And also you can release that drug very controlled manners, and and these nanoparticles also you can administer by oral, ocular, and nasal routes, and also you can deliver the drug in the specific sites. This is also one of the advantages of the nanoparticles, and also improves the stability and very index and reduce the toxic effects. And one more advantage is the nanoparticles are quickly eliminated through renal route. But why the graphene is more important than other nanoparticles? Now, graphene actually, you can see the graphene, there are two-dimensional structures, and there is two sides. Also, you can functionalize easily. If you can functionalize easily, so the toxicity of the graphene can be reduced and increase the solubility of the graphene. And because of the availability of both sides, there's a more drugs can be attached with the graphene, with for the pi interaction. And also in graphene there is toxic metals. There is no any toxic metal, and also low cost compared to the some nanoparticles. And they can deliver the different small molecules. And this graphene oxide actually, we can functionalize the graphene oxide. There is we can use the two methods basically, the covalent functionalization, non-covalent functionalization. And covalent functionalization we can use different type of polymer, you can functionalize it, and non-covalent functionalization only the pi stacking, and using the van der Waals force, electrostatic binding, and hydrogen bonding, we can non-covalent functionalization. Basically, drag can be attached with the graphene oxide surface by the non-covalent functionalization, and the polymer can be attached with the covalent functionalization. Yeah, this is different type of actually, for graphene. We can functionalize. If we can do that actually fast, if we can try to treat with the acid, definitely they can develop the more actually oxygenated group, OH, COH group, and epoxy group. From these groups, whatever you want, according to your applications, you can functionalize the graphene oxide very easily, and you can utilize it. And in our case, most of the people actually using the polyvinyl alcohol, polyethylene glycol, polypyrrolidazone. They can attach with the graphene oxide, and after that they can attach the drug, and they can deliver the drug. Or also there's actually the covalent functionalization, we have used this one. And non-covalent, just surfactant, you can use it and define DNA, and also the some polymers also you can functionalize it. And in our case, actually, whatever we have already worked on this one. That is, the graphene oxide, you can functionalize with the PVA, with the polymers PVA, and they will increase the solubility. You can see this is the graphene oxide thickness, and when you can attach the PVA, the graphene oxide actually with the small pieces, and also the thickness of the increases. And when we can attach the drug, attach the drug CPT, actually this is the cancer drug, anti-cancer drug. So this actually we can use basically the drug that is the fully water soluble drugs. So after attached, the thickness will be increased. So that's so we can say that drug is attached, and that is actually there's a different process. You can use the UV. From UV you can see the drug attached or not, and also API. Yeah, that is a different type of we have functionalization with the click chemistry, right? And the how also from the Raman actually you can see D band actually after functionalization, the D band will, the height of the D band will be increased. Actually, the ratio to D band to G band will be increased after functionalization. So that's also we can confirm from the Raman also the already will be happen. Okay, and this is different. You can see the drug release and drug attach. We can also determine from the UV, and we can see also drug release about 20% of it depends on the drugs. Different drugs that release the different one. I will show you. I'm not going to the in details because just only 10 minutes left. Yeah, this is you can see the cell viability, where you can see the our case using the our graphene as a nanocarrier. So the relative cell viability actually is less compared to the pure drug. And also we have attached, different type of PBP beta cyclodextrin, and also we can drag the SN38, and we have characterized, and we can confirm the drug will be attached, and also we can see the cell viability also in our case is lower than the pure drugs, and that is actually we have already published paper. And also we have compared actually the graphene and actually carbon nanotubes, where also we can see the both the characteristics near about the cell killing effect or about the same. Not only the single drugs, not only the single drugs, also we can deliver the dual drugs delivery also. And this dual drug delivery actually we have used the different drugs, quercetin and gyptymine, and this is also we can use, and we can see the dual drug cell killing effect is better in case of the dual drug delivery compared to the single drug, and this is definitely of the synergistic effect. Okay. Yeah, that is also whatever you can develop actually potassium dot, graphene oxide. We can also attach the drug, and we can also use the dual drug different the CPT and gyptymine also, and also in that case also we can see and our carrier system is better than compared to the pure drug. Yeah, this is already show it. Yeah, this is already better than this, and the potassium doped graphene monoxide, they show the very good fluorescence properties, so we can use as a bioimaging applications. You can see that is the we have tested in the cell, and you can see the very good bioimaging emission. Yeah, this is actually drug delivery. We have did a lot of work on that, but just I show only some work. And not only that, not only drug delivery, we are working on the different energy applications. That is the fuel cells. I know you are most of the pharmaceutical background, so we are interested in pharmaceutical, but also I'll show you some energy, because nowadays the hot research actually, this is the energy applications. So just I can show you something. This is we have developed our different type of catalyst, and actually platinum based catalyst, and this catalyst we can use in fuel cell. So our catalyst system showing the better result compared to the commercial catalyst, and also this durability. Actually, durability also our case is the better, and oxygen reactions also better for our samples. Okay, and this is the supercapacitor. Actually, I am our group actually we have moved to the energy research. I am going to actually close the drug delivery research, because some cases in drug delivery I have no facilities, because cell test I have to do in somewhere, and in vivo it is not possible to do for us, and also we are not fully biological background, so sometimes we feel that there is a problem actually for us to do this work. So that's why I switching to the energy research, and mainly in energy means supercapacitor, because nowadays someone using the batteries, but they are trying to replace the batteries using the supercapacitor, because the size of very less and energy power density, actually power density the supercapacitor is better than battery also, but there is some also many disadvantages there, and actually we are trying to develop the supercapacitor for the electrical vehicle. Actually we have already started this work, and already we have submitted the proposal to get the fund. So already actually we have got the specific capacitance near about 377 Faraday per gram. So this is the high actually using the our graphene, actually waste derived graphene. And also this graphene also we are using for the organic solar cells, and we got the efficiency near about perovskite solar cell near about yeah, there is a 12.40 efficiency. And also we are working on the DCC fuel solar cells, and this one also actually we have already published in scientific reports. I told you this is also we used the waste plastic derived graphene. Yeah, last the upcycling of waste plastics from to valuable products have a graphene, liquid fuel, and gaseous fuel. We have developed by the single methods, and our method is the cost effective, and definitely this is the greener way. There is no toxics, no any toxic gas came out environment. Actually, already pollution control board checked it and has given the certificate. And definitely our method will generate high revenue, and these with plastics can be used, defined applications. And this is the common things, the fibers: refuse, reduce, reuse, recycling, and revive. And this is our group. I think we have nowadays we have about 15 students are working on that. And also I acknowledge all students. Because of students, just I'm sitting this chair and I'm giving the very bit talk, because they are very hardworking. In Nainital, I think Dr. Orindam already visited our place. He knows how difficult to work, because in the winter time, 3 days, 4 days, there will be not electricity, also water in the lab. So
Yes, sir.
it is very difficult to work in hill area, but still we are working. Actually, I try to overcome all the problem, all the struggles, and we are doing. I think my students are doing good work nowadays. Thank you very much.
Thank you, sir, for your details and elaborative discussion related to your research work. From my point of view, it is a mammoth task, and based on the positions where you are and the situation related to your research work and the facility you have, the applications of graphene is mammoth in different dimensions. There are a lot of scope on that. I hope that our participants are enriched with huge amount of knowledge related to their research work based on your research output from the last, I think, 10 to 15 years, what you are achieved. So for me, it is a hats off to you that with all these difficulties you do doing this excellent research work. So from the participant, I am getting some questions related to the topic. First question is that graphene is very highly reactive with oxygen. So how it can be combat with problems with environment?
No. Actually, that is wrong. Actually, graphene is not highly active with oxygen, because if you can keep it the graphene, that is not otherwise if you can keep the graphene, so if they generate the oxygen group in the graphene, so in that case we don't need to treat it to develop the oxygen group in the graphene. Graphene is very stable. But after functionalizations, they will be the soluble in water or other solvents also. But before that, pure graphene is very difficult, very stable.
Okay. So I hope the participant who asked this question get his answer. There is another question that how graphene would be used as a material for liposome fabrications.
That is actually, I told you that is not my fully background in the, the pharmaceuticals.
Yes.
But I know the small molecules, whatever that is, you can attach with the graphene. That will be not a problem.
Okay.
And we can deliver it. There is not a problem. Because our students actually work. Also, I work when I was staying in Singapore. There also we can attach the DNA and different aptom also we can attach with the graphene oxide. That is not a problem. But fully the liposome also we can attach it. That is, I don't think there will be any problem.
Okay. There is another question from my side. So that you extracted the graphene as a pure form. Now, during our drug delivery process, specifically, we are using graphene oxide specifically.
Yeah, that is,
So,
that's I'm telling you. I understood your questions. It's actually whatever we have, there is the reduced graphene oxide. Okay, in drug delivery applications, definitely we can treat it and we can, generate the more functional groups, the OA, COH group, and epoxy groups. And after that, we can also functionalize with, polymers. So that's why they improve the solubility and viability of the graphene oxide. Right?
okay. Yeah, thank you, sir. So there is another question from Dr. Devabruta Ghosh Dostija, that how we can convert the bulk graphene which you were produced in the lab into nanoparticles as a bulk nanoparticle.
Graphene itself is nanoparticles. Because what is the nano means, if you can see the one direction must be follow the nano, right? So the thickness is a single layer of graphene. This is 0.33 nanometer.
Yes, sir.
Okay, but our case we are that is the graphene maybe 3 to 5 layers. That is only 4 to 5 nanometers. The
So I am just talking about the other dimension.
Now, other dimension is not for, because one, if you can talk about the nano, what is the graphene?
If you want to reduce the size of your material,
definitely.
If you want to reduce the size of the particle.
Okay, that is okay. Yeah, that is, you can reduce the size. In that case, if you can do the functionalization, that is, you can reduce the size. Otherwise, you can reduce the size means microwave explosions, you can reduce the size. Also, you can size reduce by using the ball milling. Nowadays also we are trying to ball milling to reduce the size. Actually, some cases, some applications you need the big size, and some applications you need the small size. So according to applications, we can develop it.
Yes, and for drug delivery purpose, obviously it should be smaller in size. Otherwise, you can't deliver the drug.
Definitely.
Okay, thank you, sir, and thank you, Dr. Devabruta, sir. So there is another question from Dr.
I am having. Yes, Vinanda, please.
Yeah, you can.
So, what are the conventional strategy to promote water solubility of graphene during drug delivery design based on nanotechnology concepts?
Yeah. So in that case, what you'll do actually, you have to do the functionalize of the graphene oxide. First, you have to develop the graphene oxide, because whatever you can develop, this is the graphene or reduced graphene oxide. If you can do work using the raw material, that is the graphite, so definitely you can directly you can convert to graphene oxide. Okay. And after that, this graphene oxide, you can functionalize with the polymers. Because graphene oxide not fully soluble in water. Okay, in that case, you have to, if you can functionalize with the polymers, they improve the solubility of the graphene oxide, and then you can see the fully soluble, because when you can attach with the drugs, or in the cell test, you use the medium. Sometimes you can use the DMS also, you can use it, and also the water medium. If and the during process, actually, when you can attach the drug, I think that times you can release, actually during the release, actually you can use the medium, the water medium. So in that case, if graphene oxide is not fully soluble in the water, that will be big problem. So we cannot do, you cannot apply in the drug delivery application. It is not possible. And definitely, if you can ask, sir, I need the bulk amount, because this work still in the preliminary stage in graphene oxide.
So, sir, I'm asking from 1 or 2 gram that I have purchased and I want to promote the solubility.
Yeah, why not? You can do that. Because we are also doing the same things. 1 gram or 2 gram graphene oxide, then we can functionalize and we can check it. Okay.
So yeah, dear participant, if you have any other question, please ask.
Sir, am I audible?
Yes,
Hello.
yes.
Sir, I have a question. Sir,
Yes, Santanu, you are audible.
Yeah, as we know, sir, that the bulk graphene has several layers. So if we decrease the number of graphene layers by the process of like exfoliation or so, so could we expect that the increase in the surface area and greater productivity?
Yeah, definitely. Because if you can reduce the layers, definitely increase the surface area.
Sir, so what is the easiest way to do that in the laboratory conditions? Like,
yeah, in laboratory conditions, you can use the microwave.
Sir, liquid exfoliation is possible?
Liquid exfoliation is possible, but you can see the how much cost. Actually, every time you have to think about the cost benefit. Okay. Just microwave, in microwave, actually also we are trying, we are doing the microwave also. However, you can keep the samples and just we can get energy and they exploit it.
Okay, okay, sir. Thank you.
And one more, actually for the bulk production, that is the necessary, for the bulk production of the graphene, it is, you can think about that which process will be easiest.
Yes.
So that's why, because you can develop the single layer graphene using the CVD metal, but CVD metal is very costly and time consuming. Yes. And that's why the cost, 1 layer of graphene cost is very high.
Actually, I saw several papers, several research group, they are trying to exfoliate graphenes through like protein-based exfoliation.
Yeah.
Due to the bioavailability of graphenes. That is why I am asking. Sir.
Yeah, definitely.
Okay, thank you, sir.
Okay.
Okay.
So
thank you, sir.
Okay.
Yeah, thank you, sir, for your valuable time in our first FDP from Department of Pharmaceutical Technology and in JISU University. As a small token of appreciations, this is the present and your certificate of your presentations. Please accept it in e-mode and we will send it through your mail.
Thank you.
Thank you, sir. Thank you for your valuable time.
Thank you.
So over to Dr. H.S. Maji, sir.
Yeah, thank you, Dr. Sahu, for your informative and lucid lecture. It was elaborative. Indeed, I was listening to every bit of it. I think all of our participants have enriched their knowledge and will surely keep interest in it. And with your permission, shall we share your contacts to the participants if they are more interested?
Yeah, definitely. You can share my email IDs, not a problem.
Sure.
I think my email.
May we request the presentation of you?
Actually, my presentation is very big file.
Okay.
Because there is, 3-4 video are there, so that's why it is very difficult to send stuff.
No, it's okay. We will share the email ID. To the
and participants, if you have any questions, and also I encourage you, if you do any work on graphene, definitely contact me. I will give you the graphene of free cost, not a problem. and you can do the work. There is no problem. And also, I don't need also my name also in your paper also. Okay.
Thank you, thank you, thank you, thanks a lot. So, dear participants, here we conclude our first day, first session, and we will be resuming with another link at 2:30 p.m. sharp. So, till then, bye-bye, have your lunch and get ready to join at 2:30 p.m. The joining link will be shared in your WhatsApp group. Thank you, thanks a lot.
Okay,